There. Welcome to this practice set for solving systems of equations by substitution. As always, like and subscribe to support the channel, drop a comment or question, let me know what you think, and check out the other lessons on solving systems and make sure you're not missing anything in our unit on solving systems of equations. As always, pause the video to work these problems on your own and then come back to check your work. All right, I don't know if you can hear, it is deluging outside the window at the moment. So there's a lot of rain. So if you hear something in the background that sounds like rain, it is. Okay, so we are solving these using substitution. Now, when you're looking at your system, you can solve any of the equations for any of the variables. And sometimes we get stuck into thinking, I know I've had students get stuck into thinking they always have to solve for y. Now, in this case, one of the equations is already solved for y. And so what I'm going to do in rewriting this, just to emphasize this, and I won't do this in all of them, but I'm going to change the color up. Okay, just on the y. And what we're going to do is take the 3x plus 1 from that first equation, and we are going to substitute that in for the y. Now, if you recall from the lesson, when you substitute, you take out one thing and replace it with something else of equal value, but different in some way. And what I did there with the color is just emphasize what the substitution is. So we're taking out that y, and in place of the y, we are putting the expression 3x plus 1. Now, we know that they are equal, they are equivalent because of our equation over here that says y is equal to 3x plus 1, but it's different in this key way in that now, instead of two variables in the equation, I only have one. And now our equation solving skills will kick in. We can simply remove the parentheses there. 2x plus 3x is 5x. And then we will subtract 1 from both sides. And then divide both sides by 5 to get x is 12/5. And this is a good example of one that does not come out nice. So this is one of those ones where you're like, oh, crud, really? Like now, if we were doing a different strategy, we could just kind of move on and we don't care that we got a yucky value for this, but it is what it is. Now, to find the other variable, we're going to do another substitution, and you can really substitute into either equation, but I'm a big advocate of pick the easiest one. And I'll do the same thing right here, where we will highlight that. Now it's thundering outside. Awesome. And we're going to substitute in for the x. So we're going to substitute in 12/5. And then we just need to grind this out. Now, you are welcome to use a calculator here. You could throw this into Desmos. It'll do the arithmetic for you. Let's just go ahead and do it out, though. 3 times 12 is 36, so this will be 36/5. And I want to add this to a 1. I need a common denominator, and so I'm going to write 1 as 5/5. And then 36 plus 5 is 41. And so my answer is x is 12/5 and y is 41/5. Or if you are asked to do that as an ordered pair, it would look something like that. So just make sure you're following the directions that your teacher gives you for solving them. All right, moving on to the Okay, let's take a look at this one. This one also has not awesome answers, so I'm sorry about that. Okay, so once again, we do have one of the equations that solve for one of the variables, and I do get students that get kind of locked into, oh, I always have to solve for y, solve for y, solve for y. And I mean, we do solve for y a lot of the times, but we can also solve for x, and certainly if the problem is given to us as solved for x, then that's what we're going to use. All right, now I won't do the color coding on this, but I will draw a little arrow to show us what we're doing here. we are going to take out that x right there and replace it with the expression y minus 4. And so right underneath it, there we go. And now distributing, so 3y minus 12 plus 2y is equal to 1. 3y plus 2y is 5y. We'll go ahead and add 12 to both sides. And then divide both sides by 5 to get y is equal to 13/5. Second part, we need to go figure out what x is, and I am going to use the expression that's already solved for x. I don't know what the microphone is picking up, but there's thunder, there's rain, and there's also like weed whackers going on. It is quite a thing. So my deepest apologies. If you're not hearing any of it, that's awesome. Okay, so we're going to have 13/5 minus 4. Now, to add or subtract fractions, you do need to have a common denominator. So if you're not sure how this is supposed to look, you've got like 4/1, and you want it to have a denominator of 5 because you need the denominator of 5 in order to get them to subtract. So what that means is we're going to multiply by 5/5, which will give us 20/5. And if you think about that for a moment, 20 divided by 5 is 4. And so we know that that is an equivalent fraction. 5. All right. 13 minus 20 is -7, and there's my other answer. So you could write this as the ordered pair, or you could write it as x equals -7/5 and y equals 13/5, whatever your directions tell you to do. All right, now this one, we actually have some options. So if you're looking at your work and then you follow my work, we might be making some different decisions here. So this one, none of the variables are solved for. Now we've got 3 excellent candidates for solving for a variable. Any variable with a coefficient of 1. So if I look at this system, I've got 1y, 1x, and 1y. Any of those would be good candidates to solve for. So your first step could be any one of the following. You could end up with y equals 10 minus 2x. You could have y equals 4 minus x, or you could have x equals 4 minus y. If you have any of those as your first step, then you're on the right track, and they're all equally good for solving this system of equations. So I'm going to pick one of those to work with and kind of go through the steps there, but as you're looking at your work for it. This incidentally is how sometimes as teachers, we know when students are copying, because there's 3 different ways to do this problem. And if you and your neighbor like make all the exact same decisions at every single step along the way, it's a little bit dodgy. Like maybe you copied off of each other, or you both got your answer off of Gauss or something. Just do the problem on your own. So I'm going to go ahead and pick that top equation, and I'm going to solve that for y. So that involves subtracting the 2x from both sides. 2x minus 2x is 0, leaving me with a y, and I'm going to write that as 10 minus 2x. Now, some other problems, we actually do change that over to -2x plus 10, and that's fine, but it's not necessary for this problem. Now, what is important is that you plug this into the other equation. So you do not go and plug an equation back into itself. I'll show you what happens with that, because you might be like, well, how did I get here? All right, so we're going to take that 10 minus 2x, and we're going to plug that in for the y. So plus 10 minus 2x is equal to 4. X minus 2x is -1x. And then we'll subtract the 10 from both sides. So -1x is equal to -6. divide both sides by -1, and you get x is equal to 6. And then you can plug in that into any of the others. I used to be a real stickler for making my students plug into the original equations. I didn't want them plugging into the one that solved for. It honestly doesn't matter. So I'll go ahead and plug it into one of the top ones anyway. So we have 6 plus y equals 4, subtract 6 from both sides, and we get y is equal to -2. And so my answer would be x equals 6, y equals -2, or the ordered pair 6, -2. Now, real quick, suppose you did plug it into the wrong equation. And this will happen occasionally. So you always want to plug it into a different equation. So you end up with x is equal to 6. Okay. And then you want to, oh, no, it's right here. Sorry. This right here. So you have y equals 10 minus 2x. And you have to plug it into the other equation. So suppose you didn't. So you started with this equation, you got y is equal to 10 minus 2x, and then you do this. Like, okay, y is 10 minus 2x. 2x minus 2x is 0. And this is true, but also a dead end. Okay, and so if that happened to you, you got 10 equals 10, or maybe you got 4 equals 4, or 6 equals 6, or something, then what it might mean is that you plugged the equation back into itself instead of plugging into the other equation. So just be on the lookout for that. All right, now this one we also need to do a little bit of algebra, and we have 2 candidates for things to solve for. The bummer there is that they're both negative. If I had a positive one, I would want to pick it, but I don't really have an option here. They're both negative. So if one of those was a plus y, it would tip it in favor. I'm going to go with the top one because that one just has smaller numbers. So we have 2x minus y equals 2. I'm going to subtract 2x from both sides. Remember that minus does go with the y though. Okay, and then we need to say multiply both sides by -1 or divide both sides by -1. We'll go with the multiplying here. -1 times -y is y, and then we're going to distribute that through. So we'll have -2x plus. I feel like I am not on my game. -2 plus 2x. Okay, now make sure you plug that into the other equation. So if I picked that first equation to start with, I am going to plug into the other equation. So 3x minus -2 plus 2x is equal to 5. Distributing that subtraction, and this is where that plus and negative can come in handy. If you've seen my older videos going back into how do we deal with the subtraction, how do we interpret that in our head. So this will be plus 2 minus 2x. 3x minus 2x is 1x. And then we'll subtract the 2 from both sides to get x is equal to 3. And then you can pick whatever equation you would like to figure out what y is. We'll go back to that first equation. 2x minus y is equal to 2. So 2 times 3 minus y equals 2. 6 minus y equals 2. Subtract 6 from both sides. So we get -y is equal to -4. Divide both sides by -1 or multiply by -1, or you could say if -y equals -4, then positive y must be positive 4. And so we end up with the ordered pair 3, 4. Again, you might have done this a little bit differently. You might have opted to take the bottom equation and solve that for y. There's also something you could do where you could substitute in the negative y. So you could take the -y and plug it into the other equation for the -y. That's the kind of thing that a computer would probably think to do, but not a human being so much, especially not if you're just learning how to do it. Actually, how I discovered photo math many, many years ago, I had students doing these kind of like they worked, but they were like weird little strategies where they were substituting in for like a 3x instead of an x, which will work. But anyway, that's how I discovered it, being suspicious of what I was seeing. So always better to do it on your own. Okay, so we're back to ones that are already solved. So that's nice, already solved for y. So we'll take our x plus y equals 18, and we're going to plug in 5x for that y. X plus 5x is 6x. Divide both sides by 6, and x is equal to 3. And then y is equal to 5x. So y is equal to 5 times 3. And for whatever reason, the order of these problems, like the fifth one was the easiest one. So we had those messy ones with the fractions at the outset, and that one was the most straightforward one. All right, last one. You need to fence in a yard and have 60 yards of fencing to work with. So you're looking at your fencing, you've got 60 yards worth of fence. The yard must accommodate a pool, and to do so, the length of the yard must be twice the width. Find the dimensions of the yard. So a few things we want to know. The word dimensions is a mathy word that means the measurements. And for a rectangle, the dimensions are the length and the width. Okay, dimensions are length and the width. Now, for other shapes, you might have other numbers. So like for a circle, okay, the dimensions for the circle typically will be either the radius or the diameter. Okay, one of those two. You might get circumference in there, but usually dimensions for a circle are radius. But that word dimensions means the measurements, so find the length and the width. You also need to know how to interpret the 60 yards. That's your perimeter. Okay, so it's not using the word perimeter, but if you've got to fence in the yard and you have 60 yards of fence to work with, then that is the perimeter. Okay, always draw pictures with this. Okay, pictures can help a lot. So we know that twice the width plus twice the length is equal to 60. In other words, there's your 60 yards of fencing. We also know that the length is twice the width. So whatever the length is, it's 2 times whatever the width is. And there's our system. So we're going to go ahead and take that 2w and plug it in for L. So we're going to have 2w plus 2 times 2w. 2w plus 4w will give me 6w, and that's my perimeter. So my width is 10 yards. And then you can figure out the length using either of those, but the easiest one is to do that. So we've got 2 times 10, and that'll give us 20 yards. So the width is 10 yards and the length is 20 yards. So if you were to do this out, okay, and see that it meets both requirements. The length is twice the width, and if I add all of that up, there's my 60 yards of fencing. All right, don't forget to like and subscribe to support the channel, drop a comment or question to engage, and check out the other videos and lessons that we have, especially if you feel a little shaky on your systems of equations. We're going to have all that you never knew you needed to know about systems of equations covered on this channel. So be sure to check it out. I'll see you in the next one.